Hi there, my name is Dylan O'Connell and my report is on Amazon Rekognition. In this presentation, we're going to take a look at a brief history of AWS Rekognition. We're going to play around with facial analysis demo. Then we're going to implement facial analysis with S3 and Lambda. Then we're going to demonstrate facial recognition implementation. And finally, we're going to talk about how and where this technology is used in the field. AWS Rekognition is a service provided by Amazon Web Services that was launched in 2016 and is used for facial recognition. The application of this technology is only limited by your imagination. Facial analysis and facial recognition are the two most commonly used features of this technology, but this software can be trained to look for just about anything. You can use it to identify all of the mailboxes in an image or all of the instances of pedestrians jaywalking in a video stream, anything you can think of. For simplicity, we're going to stick with facial analysis and recognition via images in this presentation. If we navigate to the AWS Rekognition site, we can see on the left side here that there are several demos available. If we click on the facial analysis link, we see that this sample image of a young woman with sunglasses on and driving a car. Here we see that Rekognition has correctly recognized a face with sunglasses and placed measurement points along her face. Below this, there is an option to upload your own picture, and that's exactly what I've done here on the next slide. Here is my picture and my results. Those little white dots in my eyes do make me look slightly evil, but that's fair enough. Amazon Rekognition gives you a lot of recognition parameters, far more than are displayed here on the right. Let's see how accurate this scan is. It says it's 99.9% sure that this is a face. So far, so good. I appear to be male with a comforting level of certainty. I'm smiling. I appear to be happy. I'm not wearing sunglasses. This is all correct. My age range is flattering in that it thinks I'm between 36 and 44, and I just turned 46. But hey, I'm not complaining about that. It seems very sure that I have a beard, but about 95.4% sure that I don't have a mustache, which is strange because I obviously do have a mustache in combination with my beard, but I'm guessing this is a case of semantics in which they're trying to say that I don't only have a mustache. In any case, with the exception of the mustache question, this seems pretty accurate. So let's go ahead and implement this facial analysis with Lambda and S3. The first thing we're going to have to do here is create an S3 bucket. Now you can do this online on the web page, or you can do it from the CLI via PowerShell on your PC. Here I have included an image of both methods. Once your S3 bucket has been created, you can upload a picture via the web page or the CLI as well. Here I've uploaded a picture of Nicolas Cage and labeled it image1.jpg. Next, we need to create the Lambda function. We hit create function and give it a name, selecting the newest Python runtime environment. After we do this, we need to be able to get access to the Detect Faces API, which means that we're going to need to add some permissions to this Lambda function, which we do from the associated role in Identity and Access Management, IAM. Here we need to add Amazon Rekognition read-only access and Amazon S3 read-only access. Now when you go back and check your permissions under your Lambda function, you can see the added resources under the summary. Next, we need to enter our Lambda code to make calls to both S3 and Rekognition. We need to import the VOTO3 library, which is Amazon's software development kit for Python, in addition to the JSON library. Next, we need a reference to the Amazon Rekognition client, which we do on line 4. Then inside our Lambda function, we need variables for the image bucket, where our images are held, and the name of the image in question as well. Next, we create the response variable, which we use to call the Detect Faces function, which we then specify the bucket and the file name, and tell it to return all attributes that it can about the image. And this is a lot of attributes. This can give you a lot of information if you don't filter it out. We're going to run this code by hitting deploy and then creating a test point and then executing it. Here we can see the results of this facial analysis with my buddy Nicolas Cage. The algorithm tells us that he's not wearing any sunglasses, he's not wearing regular glasses, he's very likely male, doesn't have a beard or a mustache, and a litany of other return values that are cut off. And this is a demonstration of just how easy facial analysis is to set up with S3 and Lambda. Honestly, very simple to do it this way. For our next operation, we're going to need to change things up slightly. Now we're going to try out facial recognition. And to do that, we need to train our model on what a few people look like so that it has a basis to recognize them later. This Python script takes the contents of your S3 bucket, pulls them into Rekognition where they are analyzed and converted to binary. They are then uploaded to the previously generated table in DynamoDB along with the metadata that Rekognition pulled from them based on the bulk upload of the images, which I will show you later in 2 slides. Here is our AWS Rekognition collection and DynamoDB table creation via CLI. If you find yourself doing a lot of work with AWS, then the CLI is really the way to go. It's a lot quicker and simpler to execute. Here we have 2 Python scripts. The first one, labeled putimages.py, is uploading 6 sample photos into my S3 bucket, along with the name of the person in the picture. This is so that later on, when these images are compared against 1 or 2 of them maybe getting a hit, it has a name to return with the value. The second Python script is designed to take the local picture, convert it to image binary with Rekognition, compare it to the table in DynamoDB, which is set to pull images from our S3 bucket whenever they're uploaded to it. The table name is different between these slides. I just realized that. I was doing a lot of troubleshooting at this point, and did eventually get it to work, but yeah, this is a little more complicated than the last technique. And this is the final slide here. It shows the results of using the testing.py script and giving it a new picture of Elon Musk, which it converts, compares, and returns the correct value for. This type of technology is used in place of badges and key codes in various companies already. Some of the companies that already use AWS Rekognition include Ring, which is an AWS company. Ring uses facial recognition for identification and alerts. Motorola, who integrates Rekognition into their video analytics capabilities. Marinus Analytics, which is a company that helps law enforcement and security agencies recognize human trafficking victims through video surveillance. And the Shanghai Metro, which uses Rekognition for facial recognition and crowd monitoring. And that concludes my demonstration. Thank you very much.